Hi, good morning. This is the Gardener community meeting. It's a pleasure to me to welcome Aylei from PingCAP and Matt Sauer from Schwarz IT, who will talk today about their experience using Gardener. And they also brought some questions and feedback. So I think this will be an interesting session. So now I will unshare and then Aylei can start.
Thank you, Sun. Let me share my. Okay, can you see the slides?
Yes.
Yes, all right. Hi,
It's
everyone.
not yet in presentation mode.
Yeah, I will make it full screen.
Yeah.
Yeah. Hi, everyone. I'm Aylei from PingCAP, and I'm going to talk about how we use Gardener to build our database as a service. And because my English is poor, so please don't hesitate to
Just take your
interrupt me
time, no problem.
if you have any questions. Yeah,
Yes.
if you have any questions. So I will begin with a question about what have we built on Gardener, and then I will talk about why did we choose Gardener, and I will elaborate how we build our database as a service on Gardener. And finally, I and some of my colleagues have prepared some questions that we want to ask the community. So let's begin. First, what have we built on Gardener? Actually, we have built a managed database as a service, as known as TiDB Crowd on Gardener. And here's a quick demo. Yeah. PingCAP is the company behind TiDB, and TiDB is a distributed SQL database, and TiDB Crowd is, to put it simple, is a managed service of TiDB provided by PingCAP. And this is our nightly development environment, and I'm going to create a database to show the basic functionality of our product. First, you could simply select a name and password, and then select the cloud provider. We are planned to support AWS and GCP when the product is released. And now only AWS is supported. The GCP support is still under development. And select your region and your plan. And because TiDB is a distributed database and it has a compute layer called TiDB, and the storage layer known as TiKV, you could adjust the number of TiDB instance and the TiKV instance here. So which I will talk later, that TiDB is horizontal scalable, and you could select the storage nodes TiKV here, and let's go. Yeah, a new database is creating, and because it may take some time, so I create a database, a TiDB cluster in advance, and to show the basic functionality. Yeah. In this row is the TiDB nodes, which is responsible for computing SQL queries. And in this row is the storage nodes known as TiKV, which provides KV API to TiDB and is responsible for storing data. And as you can see, TiKV is evenly distributed across 3 available zones to gain the highest availability. So let's return to the slides. So TiDB is a distributed SQL database, and it is MySQL compatible. And the most significant feature of TiDB is horizontal scalability and fault tolerance with Raft. The storage layer of TiDB will replicate data to will distribute the data to 3 replicas, and the storage layer can tolerate up to 1 replica failure, and the replica could be then recovered with Raft protocol. And in TiDB Crowd, we want TiDB Crowd to be fully managed and multi-tenancy, which means that we want to provide an isolated environment for our customers, and we have to support different cloud providers because user have to connect TiDB via VPC peering. So we have to create the database on the cloud where our customers located to reduce the connectivity overhead. And the TiDB Cloud must be secure so we can let our customers trust us. And the last one is that we want to be cost efficiency, not only for machines, but also for human power. And so why did we choose Gartner to build the TiDB Cloud? Honestly, we really have concerns at the beginning. The first concern is adoptions. Actually, we didn't see lots of adopters when we are investigating Gartner. And the second one is complexity. When we build our experimental cluster using Gartner setup, we see lots of components. Yeah, and lots of controllers and lots of custom resources, which is overwhelming. And everyone at PingCAP is just say, oh, look how complex Gartner is. And the finally concern is a question that we've asked internally frequently, that why not choose a managed Kubernetes service like EKS or GKE? Because as we know, managed Kubernetes service often offers lower price comparing to set up your own Kubernetes masters on EC2 or GKE instance or GCP instance. And managed Kubernetes service will take care of all the things, and you don't have to worry about the upgrading and the maintaining. So why not choose a managed Kubernetes service? These concerns are soon be eliminated when we get familiar with Gartner. First, about adoptions, we think good product speaks for itself. Once we get familiar with Gartner, we quickly notice that the concepts are really similar to Kubernetes, and we can understand that Gartner is highly extensible, and also it provides a unified and beautiful abstraction upon the API layer, so that we could manage machines via machine controller manager for different cloud providers and don't have to worry about the cloud specific APIs. So we think for functionality, we don't have to see the endorsements from other adopters. We trust that Gartner could do the job well. And for complexity, actually, we quickly noticed that building a managed Kubernetes service is never an easy quest. So we think the complexity is worth it. Even if we build a managed Kubernetes on our own, we will end up with a more complex platform. And finally is the most important question, why didn't we choose a managed Kubernetes service? Actually, we have, when we are developing the first version of TiDB Crowd, we actually choose a managed Kubernetes service like GKE and EKS, but problems happened. The most important, the most painful point about managed Kubernetes service is that we are passive on malfunctions. Problems can happen due to cloud provider upgrades. It's not about upgrade the Kubernetes master. It's about the once upon a time, the GKE team upgrade the system that runs GKE, and our GKE are influenced. And there would be a huge delay waiting for the support response. You can get a quick response actually if you are willing to pay thousands of dollars to their support team per month, but actually it's too expensive. It's too expensive. And the second point is that there's a lot crowd-specific integration work when we are integrating managed Kubernetes service provided by cloud providers like EKS and GKE. For example, you have to integrate the GKE and EKS API separately, and also you have to integrate the instance API like EC2 API and GCP instance API. But with Gardener, you get a unified API of all clouds and don't have to worry about so much specific integration work, because even though we just support GCP and AWS now, we are planning to support like Ali Cloud and Azure in the future. So this is important for saving our development work. So finally, let's see the pros we see in Gardener. First, Gardener is cloud agnostic. Like I've talked before, like I've talked in the last slides, that we don't have to worry about the specific integration work, and it's real. When we complete the integration work about AWS, we found it's really easy to make TiDB Crowd run on GKE and run on GCP. And the next is ease of management. I would describe it with the familiar concepts, because Gardener has familiar concepts with Kubernetes, like seed is just like Kubernetes node, and each Kubernetes cluster you manage it now as shoot is just like a Kubernetes pod. So the similar concepts and the controller pattern makes Gardener very easy to manage, and also it's easy to extend, because all the SRE team at PingCAP has already been very familiar with Kubernetes. So it's not hard for us to hack and extend Gardener. And finally, we see that Gardener has an active community. Every question that has been asked in the Slack channel get response quickly, and the response are usually really helpful. So here we come the interesting parts. How did we build a database as a service upon Gardener? Let's take a quick overview. First, we have a base cluster globally, and we set up a seed cluster per cloud provider per region. For example, for AWS US West to Oregon region, we will set up a seed cluster, and our DBaaS management service will dynamically provision a shoot cluster for each tenant, cloud, and region triple, so that each tenant will have their dedicated shoot clusters, and they get the best isolation because each shoot cluster will have a dedicated VPC and other infrastructures. And finally, a shoot cluster will run one or more TiDB clusters. And here's an architecture diagram. First, we deploy a management service known as the central in base cluster. And the central is also the API gateway that is user faced. And then the central will also talk to the central will talk to the Gardener API server to create and scale shoots. Yeah, you may be curious about why do we scaling shoots? Why shoot is not auto-scaled, which I will explain later. And the central will also talk to the API server of shoot to deploy and reconcile components in the shoot cluster, like some control components and the TiDB clusters itself. Let's break it down. First, the central. The central is deployed in the base cluster and it's a singleton globally. All the operations triggered by by user are stored in the database first and applied asynchronously. Just like Kubernetes that store the resource in etcd and apply it in controllers asynchronously. And the central is responsible for managing shoots and the TiDB clusters in shoots. When a user, for example, when a user create a cluster in the TiDB Cloud UI, the central will first provision a dedicated shoot for each tenant, so we get the best isolation. And then the central will reconcile dbus control the TiDB Cloud control components in the shoot, including TiDB operator, an Kubernetes operator that orchestrates TiDB, and our usage reporter, which is used for billing, and an API proxy, which is responsible for proxy the TiDB API to front end. For example, we see the monitorings. We see the monitorings here, and like the key visual dashboard here, it's actually proxied from the shoot cluster. From the shoot cluster by proxy to central and to our front end. And after create and reconcile the shoot, we provision dedicated node pools for each TiDB cluster in shoot. And for best isolation, we will provision dedicated node for each database pod. And in addition, to guarantee the nodes are distributed evenly across available zones, we will create a dedicated worker group for each available zone. So after the cluster is deployed, it will be, all the pods will go to a dedicated namespace, and it's just like this, because TiDB has many components, and I'm not going to explain all of them today, but as you can see, those pods conforms the TiDB cluster. And let me explain why we choose to create a worker group per available zone. Because at first, we try to create a worker group per region for across three available zones. But when we scale out and scale in the worker group, we witness that the machines in different available zones may be uneven. For example, when we scale machines from 3 to 6, one of the available zone gets 3 machines, and it's the machine deployments. One of the machine deployments gets 3 machines, and the other get 2. And when we scale it from 6 to 5, the machine deployment of the available zone with 2 machines are scaled in, but the available zone 1 does not get scaled in. So we determined to create dedicated worker group in each available zone and control the node count in each available zone in the debug center. So this is why we have so many worker groups that even exceed the limit. We encountered the problem when we create 3 TiDB clusters under one account, and these 3 TiDB clusters will go to the same shoot. So the shoot will have about above 30 worker groups, and we met a limitation that we cannot create more worker groups. Luckily, with the help of the community, we've fired a pull request to fix this. And another challenge is local persistent volume. This is a big difference with TiDB, between TiDB crowd and other stateless applications that may run on Kubernetes. Local PV is local volume as persistent volume. And it's also consumed by persistent volume claim. The benefits of local PV compared to remote block device like EBS is that it offers low latency, and typically it is much cheaper than EBS. You may wonder that, okay, EBS provides higher data durability because it replicates data to multiple replicas. It costs more, but maybe it's worth it. But actually, EBS is not only cost more, it costs much more. For example, NVMe local SSD that attached to EC2 with 20,000 dedicated IOPS charges $0.22 per hour per terabytes. However, EBS IO1 with provisioned IOPS 20,000 will charge 1.68 per hour per terabytes, almost 10 times compared to local SSD. So we choose local persistent volume for TiDB crowd in favor of cost efficiency. However, no free lunch. Local persistent volume also brings lots of problems. The most important problem is that local PV is bounded to, has a bounded life cycle with node, which means data in local volume get lost once the instance is terminated. And note that we store all the database data in local volume. So the local volume is of the durability of local volume is of vital importance. We are there to do this because in our storage layer, by default, we store data to at least 3 replicas, and it is configurable. We could configure our storage layer to store data to 5 or more replicas to guarantee the durability of data, even if we use local volume. And plus, pods associated to local PV is bounded to the node, which means it's hard to do failover when a pod associated to local PV is down. It can only be recreated in the same node because it is attached to a local PV. So we want to disable automatically machine termination because machine termination will cause data loss of local volume. Also, we want to upgrade the kubelet in place when upgrading Kubernetes. We knew that the best practice to upgrade Kubernetes is just replace your node with a newer kubelet version. But for the scenario that local persistent volume is used, upgrading in place is maybe a better strategy. So we see that machine deployment assumes that nodes are stateless and could be replaced. But using local PV breaks this assumption. And this is the biggest obstacle when we using Gardener. Luckily, we could extend Gardener to fit our needs, which is impossible for auto-scaling group on public cloud. And again, extensibility rocks. Without Gardener, we won't have to run the stateful applications like TiDB on Kubernetes that well. So that's all of my presentation. Any questions?
Hi, Aylei. This is a fantastic presentation. Thank you so much for this. My name is Vasu, and I have a question around your worker pools, more or less. I mean, couldn't you devise, let's say, a scheduler mechanism instead that kind of schedules your worker pods or your pods accordingly to your design? Like was that considered?
You mean distributed pods evenly via scheduling policy?
Well, you could have your own. Let's say let's imagine you only have one large worker pool group, right?
Yeah.
Yeah. And you could lay out basically a naming mechanism and a labeling mechanism, and you have your own scheduler. And we got the similar question, by the way, from our database teams around this. And then you can basically lay it over and say, okay, I've got these 10, 20 nodes, and in my scheduler knows what purpose each of these nodes have.
Yeah.
Would that be an alternative?
Yeah. Thank you, Vasu. Of course, it would be an alternative, and actually, we've not considered that way. So maybe it's a little. It may take some time for me to understand it and prototype it, because to me, if we use a large worker pool and label the nodes by another process, I think it would bring some management burden, because when you scale down, for example, because we use local persistent volume, when you scale in a TiDB cluster, you have to scale in exactly the node used by that cluster. Mm-hmm. Yeah, and this is an extra burden. If we provision dedicated worker group for each TiDB cluster, then scale in would be easier to do, because we only select yeah, actually I'd admit a larger worker group has little difference with dedicated worker group per TiDB cluster. The only difference is that maybe the management burden will be will be different, I guess. And so I'd assume that it's a trade-off. Yeah.
Mm-hmm. Okay, got it. On the kubelet upgrade, which you were asking, I let maybe Vedran or Hardik answer that.
Or Raphael.
Oh, Raphael, yeah.
Yeah, because the kubelet update for patch versions we do in place for minor versions, it was more a decision we took back then to not do it because more things might change there, and we might have to respect whatever happens there. So that was the reason we didn't do it. We didn't want to introduce it right away to keep the door open. But if Raphael is in the call, I think he is.
He's
muted. Something to add.
Yeah, you basically summarized already the rationale behind it. But I think it's also not too difficult to make this configurable. So it's basically just a different way how this hash is computed for the worker pool. So if you would omit the Kubernetes version there, then also a rolling update when a minor version upgrade is done would not happen simply. This is something that could be made configurable, I guess.
Stefan Meyer here. I'm one of the guys from Metalstack.
You are hard to understand. Can you come closer to the mic?
Yeah. Is it better now?
Yep.
I'm Stefan Meyer. I'm one of the guys from the Metalstack team. We provide produce Gardener on top of the Metal cloud, which is with our own, and we have also local PVs on NVMs directly attached to the machine.
Stefan, I think you're still unheard, so I think it's very tough to hear you. So if you can just come closer to the mic, that would be.
I'm sorry, I'll come back.
Okay.
Because I saw Aylei trying to approach the screen, trying to hear what is being said.
Thank you for your consideration.
No worries.
Yeah. So,
is it better now?
Yes.
Yes, better.
So I try again. Sorry for the confusion. I'm Stefan Meyer. I'm from the Metalstack IO team. We produce Garden on top of bare metal cloud, which we built by our own. It's open source as well, and we have physical machines working as Kubernetes worker nodes, and also NVM disks locally. And we face the same local PV problem you described, Aylei. We implemented a mechanism to reinstall the existing machine instead of replacing it. Not yet integrated into the Gardener lifecycle, but we will do something like this in our extension provider. Second question for me is your TiDB open source product, and could it be probably also implemented on our bare metal cloud as well? Would be an interesting use case.
I'm sorry. What do you?
Well, I'm sorry, it was a bit too fast, probably. We created a cloud for Kubernetes as a service on bare metal, not on virtual machines. We have physical machines instead.
Oh yeah.
So no virtualization in between. And my question was if TiDB is open source, or can it would be interested. I would be interested in having such a setup running on bare metal instead of Amazon or something like this.
So the question is whether TiDB is available also in an open source fashion.
Yeah. Yes, TiDB is also available because it's an open source program. So it's available for on-premise data center and for any other Kubernetes platform. TiDB Cloud is only our managed product of TiDB.
Okay.
Yeah.
Thank you.
Do you have a link for this? Can you send a link in the chat where I find the open source product?
You mean the
Okay, perfect.
Mm-hmm. I have one more question. This is Vasu again. So, I mean, if we have our Gardener landscape running at SAP, would you be able to connect to our API and basically keep your and offer us TiDB as a managed service into our environments, or would we need to change some of the way how we create the shoots? Is that is that a prerequisite?
I think it's not hard and it's really doable, because if the shoot expose its API server to the debug central, and our central could deploy the control components like TiDB operator to the shoot cluster, and then install TiDB clusters in it. A special case may be local persistent volume without special configuration. Maybe the TiDB cluster can only use EBS or remote disks. It will have a slightly compromised performance and cost efficiency, but it will run well.
Perfect. I'd like to do a small follow-up, maybe after the sometime later, and see how we can connect your offering into our landscapes. And let's see, maybe we have some takers for MySQL scale out database. I mean, this is very interesting. Thank you so much.
Yes, thank you, Versu.
Thanks, Aylei. I think we should go to the next topic because we are already a bit late in time. I think we're happy if you would join the next meetings if there are more discussions. So I would propose maybe there's one last question and then we go to the next topic.
Okay, I will end the sharing, and thank you, Son, and sorry for the delay.
No problem.
So I just want to ask one last question, if possible. So you've said why you use Gardener and so on, but how did you find out about Gardener?
Tanix, could you talk about this?
Who?
Hi everyone. I'm Tanix. Yeah, I'm also from PingCAP. Yeah, I think I found the Gardener by link in Hack News.
Hacker News.
Yeah.
Yeah.
Oh, okay.
Okay.
Nice.
Yeah. Previously, we also used COPS on AWS, but found that it's unusable on other clouds like GCP and other clouds. So we've investigated the Gardener in this year for about several weeks, and then decided to use Gardener.
Nice. Thanks.
Thanks a lot to the PingCAP guys. And now we can proceed to the Schwarz IT. So Matt, it's your turn now.
So yeah, share desktop. So yeah. So hello everyone. Yeah, we are pretty new at Gardener, or in contact with Gardener, and we made our first steps with it. And I would like to introduce us and make some questions afterwards. So yeah, And the Stackit is a Schwarz Group digital umbrella brand for IT services. We are planning to start in the end of the year for public market. And behind Stackit, there stands Schwarz IT, which is a central IT service provider for Lidl and Kaufland. We are the 4th biggest retailer worldwide. And Schwarz IT operates also one of the largest sub-retail systems. We are located in Heilbronn in southern Germany. That's roughly in half an hour from the Gardner guys by car. So we are pretty close together locally. And today we would like to talk about Gardner at Stackit. And yeah, oh, sorry. So Gardner at Stackit. Yeah, that is the agenda, introduction, our feedback from our initial Gardner deployment, and then further questions we have to the Gardner guys or the Gardner community. Yeah, the introduction I have already made. So we will building Kubernetes as a service for the internal and external market, and yeah, we decided to build this Kubernetes as a service with Gardner. And regarding to our needs and concepts, we will use Gardner with IPv4 and IPv6 dual stack networking. As I heard in the Slack chat that there's not that much information about it, and someone told me that no one has proved this. So it's pretty interesting for us to get this done. And yeah, on this topic, we are also interested on feedback from the community and who may also interested on this, and maybe who is interested as a potential customer or something like that for Kubernetes clusters with IPv6. Yeah, and we made our first step, and yeah, and want to share our experience. And maybe there are some listeners who already tried this and have some experience to share. We will appreciate that, and we are interested. So, and now I would like to hand over to Alex. He has some work done with the Gardner OpenStack integration, and yeah, and can a little bit talk deeper than me, technical, about the issues and the challenges. And yeah, so, and maybe Alex, you can talk more detailed about these topics.
Yes, thank you, Matt. So this is Alex speaking. I'm also working at Stackit for the Kubernetes as a service thing. And we tried last week and this week the OpenStack integration of Gardner and had some issues. I think implementing something with OpenStack is always a challenging thing, because there are a lot of OpenStack distributions, and no installation is like another installation. So you always have some custom settings, some custom configurations, which always results in implementation problems, maybe with the one or the other programs. So we at Stackit are running OpenStack Queens at the moment. we are searching for an upgrade path, but that's our latest release at the moment. We tried with Gardener this and last week the implementation of Kubernetes as a service, and had some issues with load balancers and storage classes. At the moment, we are using Octavia for load balancers, which is okay for the moment, but yeah, we had some load balancer issues for example, for the VPN shoot connection and some settings there. There were interesting things with storage classes. So Gardener is installing per default a storage class, which is called something like Gardener Cloud Fast storage class, which in our case had, for example, the wrong provisioner. We are in the seed cluster. We are using the CSI Cinder provisioner. So yeah, this was the challenges mainly with the OpenStack integration, and for that we also had fun with the dual stack IPv6 configuration of Kubernetes. That's all from my side. Thanks.
So, yeah, brace yourself. IPv6 is coming. Yeah. Yeah, we have also further questions for the community. One of the questions is it possible to disable network policies for debugging, development, or sandboxing? Yeah. And the other question is there an overview available for all the mappings of the custom resources to the Helm charts? There's a lot of stuff there, and it's hard to find out which is responsible for what. And I think it would be great help to have a map or something like that to get a better overview.
Okay, I mean, regarding the network policy side of things, so we have, so if you're doing experimental things, then we have an annotation that allowed you to ignore reconciliation, which basically means that if you delete the network policies, they will not come back. So if you want to experiment without network policies, you can simply just delete the network policies, given that you have already disabled reconciliation on your shoot cluster. So that is that is one way you can do it. Like yeah, your seed is basically also a shoot, and if you disable reconciliation in the control plane and for the control plane components, also there will be no network policies.
Okay, thank you.
Yeah. And to my knowledge, there is no, I mean, we don't have this direct mapping, but there are extension repos, and we have the examples folder for every extension, and every extension repo have its own charts folder. So if you navigate to that charts folder, then you basically find all the charts corresponding to that special component. The only other component that is not really that special is Gardener main, and Gardener main has many subcomponents named by control plane, monitoring, networking, or core. And basically, every folder reflects on what it does. Every folder name reflects on what it does. For example, core is for the core system components that are installed in the shoot. Seed monitoring is basically the monitoring. And for all the documentation, you can then just try to navigate to Gardener Cloud or ask questions on the Slack channel, or even help us build this mapping between this custom resources to Helm charts once you get answers to the question. Or if you really need them now, we can just, I think, also bake it in.
Okay.
Another thing, can you hear me?
Yes.
Yes.
I mean, the easiest solution is, if it's only for testing, is to simply not deploy any network policy controller. So currently we're using Calico by default in all our implementations. So, but if you don't deploy it, then there is nothing to enforce the network policies. So this is like the dirtiest and quickest solution in order to just to verify that everything, let's say, it's working without any enforcement. And then you can actually build enforcement on top of it.
Okay, that's also a good idea. Yeah, thank you.
But without deploying Calico, you do not have networking on the cluster.
No, it's not separate. You can depending on the configuration of Calico. Calico can work as a networking as a CNI provider for like the networking, and it can also enforce the policies. So it depends on the configuration.
That is true, but currently we don't expose such setup, because if you do that, then you would have to set up networking also on your own, right? So we can expose it if really many people want that for experimental reasons. But I think this is an option. Of course, you can do that. But if you don't want to set up networking yourself, like given that you already don't have networking across lots of nodes, then that is not the option. But if you can do that, maybe we can help you also configure that. But I think the easiest way, I would say, in my opinion, is the deletion route. The other one also is possible, as Martin said.
About this thing, my currently in our network policies, if I recall correctly, we have a lot of IPv4 network policies, such as like to be able to talk, for example, to all IP addresses, and I guess when you do IPv6, this is not going to work.
Yeah, that's exactly our problem at the moment. Yes.
Yes. Okay. So my suggestion, if it's only for testing, then just do one of the things that either me or Ado proposed, and then just open an issue, and then I'll, for example, either me or someone else in the team, or even you can work on a PR just to also add IPv6, at least for the network policies, which are more or less generic ones. For the generic ones, which are, let's say, with IP addresses, such as the private nets and some other things as well.
Mm-hmm.
There's also one option, I would say. So Tenix already from PingCAP mentioned about the reconciliation flow in Go, and basically everything we deploy to our seeds is there in the reconciliation flow. So you can, for example, find out where the network policies are deployed and simply comment that if you're really doing testing and want to find out stuff. So this is also another option, but requires more, I would say, understanding of the reconciliation flow of Gardener, which I think along the way with your experimentation and journey with Gardener, you will be more familiar. And of course, we're happy to answer questions.
Okay, thank you very much.
Anytime.
Oh, thank you for your feedback. So we are now finished with our presentation.
So thank you very much. This is Vasu again for your presentation. I guess we will follow up via Slack and the other methods of communication to follow up on your requests. And
okay.
Yeah.
Thank you.
Maybe one question from my side, because you mentioned also outdated documentation and stuff. Just a heads up, we are currently in the process of refactoring the whole website, including the documentation. So stay tuned. There are going to be changes for good there. But one thing, if you notice that there is something wrong with the documentation or something is not quite there, please feel free to raise an issue so that we can have awareness of that and act upon that, or directly file a PR if you want. You're most welcome to contribute also to the documentation. It's also collaborative effort as everything in the Gardener. So most welcome.
Okay, thank you very much.
Yeah, thank you.
I have one more question. So have you actually tried the dual stack in Kubernetes without, I mean, just as a Kubernetes in general? So because if I recall correctly, there were at least a lot of software is already written with the assumption that it's going to run on IPv4 at least. And like those stacks often, I mean, some software components simply do not work by default, or it needs to have some fixes there. So did you have any experience with this thing, or?
So I might jump into this. I'm also from Schwarz IT, and
so we had some issues regarding Helm charts that when you run a cluster in dual stack, you need to specify an IP family in services. But most application support the IPv6 so far. Most of the times it's just some configuration or validation of a configuration which is not working properly.
Okay, but there were not any blockings from. There were no some huge problems from some component which is, for example, not running or not running by default or something like this.
No, not application specific stuff, but rather than network policy stuff. So
okay,
they were not applied properly. So thank you for the question, right?
Thanks to the speakers. Are there any more questions or any more topics? If not, then see you next time. Bye
Yeah,
bye.
thanks.
Bye.
See ya.
Thank you.
Bye bye.
Thank you very much.
Bye.
Bye bye.
Bye.
Bye. Thank you.
Very nice. Bye bye.